Pakistan's military has confirmed the interception and destruction of 25 Indian drones across multiple locations, including Lahore, Gujranwala, Rawalpindi, Chakwal, Bahawalpur, Mianwali, Karachi, Chor, Miano, and Attic. After Pakistan Air Force aggressive response to Indian Air Force attacks, 5 Indian fighters shot down including Rafale, Indian Air Force changed its strategy and used drones. The drones used by India in the latest attacks were identified as Israeli-made Harop Mk2 models, which are high-altitude surveillance UAVs capable of flying at up to 35,000 feet, beyond the range of most standard anti-aircraft guns. The engine, produced by UK-based UAV Engines Limited, was recovered intact with visible manufacturer markings. This marks the first successful interception of this drone model globally. The Harop loitering munition combines the advantages of a missile and an unmanned air vehicle (UAV). Harop is launched from a canister, reaches a holding area, where it may loiter for hours conducting critical intelligence, surveillance and reconnaissance (ISR) for the mission. Once it finds its target, the Harop proceeds to the attack phase, detonating itself on the target. The Harop uses a man-in-the-loop control mode which is operated by a remote mission operator. The Harop operator can select static or moving targets detected by the aircraft's electro-optical (O) sensor. The IAI Harop has an endurance of over 6 hours of flight and a range of 200 kilometers. IAI developed a smaller version of the Harop for more tactical missions and ranges, naming the product Mini Harop. The Mini Harop is designed to be launched out of canisters on tactical military vehicles like the Joint Light Tactical Vehicle, JLTV, and has a mission endurance of 1 hour. Mini Harop is typically used against time-critical targets or targets that hide and reappear. Using its electro-optic seeker and without prior intelligence, Harop has a 9-hour endurance to seek targets in a designated area, locate and identify them, plan an attack route, then pursue the strike from any direction at a shallow or steep dive. Harop overcomes challenges in communication with its immunity to GNSS jamming. As a guided weapons system, Harop is supervised by remote human-in-the-loop mission control and may be aborted if required. Launched from canisters mounted on trucks or naval vessels, Harop is easily deployed from diverse terrains and environment. Its maximum speed is 417 km per hour, 259 miles per hour, with range, 200 km, 120 miles, endurance is 6+ hours and service ceiling is 35,000 feet. Armament is 16 kilograms, 35 pounds, warhead and circular error probable, CEP, also circular error probability, CEP, less than 1 meter, 3 feet 3 in, with 16 kilograms, 35 pounds, warhead. The Indian Air Force also uses Heron Mark II drone, a high-tech aircraft with both strike and surveillance capabilities, capable of conducting missions along the borders with China and Pakistan in a single sortie. Indian Air Force inducted the Heron Mk2 has joined IAI's Heron family of UAS, serving air forces, armies, and navies worldwide for over 2 decades. With a new airframe and wings tuned to maximize performance, advanced avionics, and a ground control system, the Heron Mk2 introduces new mission capabilities, efficiencies, and autonomy standards. Equipped with a comprehensive payload suite, this medium-altitude long-endurance, MALE, UAS supports multiple payloads operating over a broad spectrum enable real-time collection of intelligence, surveillance, target acquisition and reconnaissance, ISTAR, covering large areas of interest. Dedicated sensors allow the system to perform standoff reconnaissance over long distances or persistent surveillance over a wide area. Additionally, the Heron Mk2 can carry maritime surveillance radar, synthetic aperture radar, SAR, electronic surveillance measures, ESM, and communications intelligence, COMINT. The Heron Mk2 provides a complete, multimodal intelligence gathering capability on a single platform by operating up to 6 sensor payloads simultaneously. The Heron Mk2 also incorporates integral wideband satellite communication and fully digital line-of-sight data links, serving multiple payloads simultaneously and allowing the platform unrestricted operational envelope over long distances, sea, land, and mountainous terrain. Switching between the different data links can optimize the mission to become covert, secure, and resilient. In addition to streaming live sensor data to the ground, the Heron Mk2 also has servers on board, providing users access to large amounts of raw or processed sensor data collected throughout the mission and stored on board. Supporting flexible payload integration with a wide range of Heron family payloads and customer-furnished systems and applications, the Heron Mk2 conforms to open architecture with separate flight control and mission management systems. This enables the manufacturer and users to maintain optimal upgrading cycles and avionics flexibility throughout the UAS life cycle. The dimensions of the Heron Mk2 have been increased over its predecessor, extending the fuselage to 9.7 meters and the almost 17 meters wingspan, providing a larger space for internal and external payloads, including underwing stores, without degrading performance. The system is certifiable by Design for International and Military Airworthiness Standards. The new power plant uses an aviation-certified engine that delivers 160 horsepower, specifically tuned to have a high climb rate and efficient operation at low and high altitudes up to 35,000 feet. The powerful motor also provides sustained power for a maximum airspeed of 145 knots and a faster ascent, improving the drone's rate of climb by more than 50% over legacy systems. The maximum takeoff weight, MTOW, has increased to 1,430 kilograms, including a useful payload of 490 kilograms. Heron Mk2 has a mission endurance of up to 45 hours. Another forte is its ability to endure adverse weather, with de-icing systems enabling the aircraft to cross stormy weather it may encounter on its flight over mountains and sea. Special attention is given to protecting the communications, navigation, and flight systems from jamming and spoofing, safeguarding the GPS and data links against interference and cyber attacks. The platform maintains self-awareness throughout the flight, preventing location deception, unauthorized intervention, or hostile takeover of the autonomous platform. The crew uses the Unified Control System, UCS, to control the mission, leveraging the highly automated and intuitive user interface to reduce crew workload and focus on the task rather than fly the platform. This modern mission control center comprises multiple displays, hands-on stick and throttle, HOTAS-like controls, and a tablet with a touch screen. Autonomous taxi, takeoff and landing and multiple redundancies for flight and mission critical systems are fully supported based on proven and robust automation, multiple sensors, and systems. Since its introduction in 1994, the Heron family has been operational with over 22 customers worldwide, accumulating well over 500,000 flight hours. Heron MKII takes the system to new mission capabilities and performance levels, setting a new benchmark for advanced male UAS. The use of these drones also reflects Pakistan's air defense systems lacking. No man-pads including Anza and Stinger was used. Anti-aircraft guns was used after initial attacks. Many of these drones reached more than 100 kilometers inside Pakistan. These two drones captured and send real-time information of Pakistani army and nation readiness level, which is more dangerous threat. Pakistan Army and Air Force have more advanced variants of drones acquired from Turkey and China, but they were not used.